Hello and welcome to another video where I look at physics questions, past papers, GCSE and also GCE A-level. Today I'm looking at the paper 1, Science A, Physics 2015, that's the foundation tier. I've already looked at questions 1 to 4. Today I'm going to look at question 5. So let's go to question 5. And here is question 5. So question 5 says the following. Figure 8 shows a solar thermal power station. Okay, so that's figure 8. It shows a thermal power station for solar. Okay, so we've got an array of mirrors around the solar receiver, which is at the top here. So energy from the sun is directed at the solar receiver by many mirrors, as we can see. So just one reason why a solar thermal power station is built in a hot desert, and that's only one mark. So it's really tempting to just say because it's very hot, okay? But which is the reason why they're saying in the question it says it's built in a hot desert, just to throw you off the mark. So basically there is infrared radiation coming from the sun, okay? And that infrared radiation is the reason why a thermal solar power station is built in a hot desert, because you need these mirrors to direct the infrared radiation to the solar receiver, which is then responsible for the generation of electricity. Okay, so the answer to that one is the fact that there are high levels of infrared radiation which are coming from the sun. Okay, if you just say it's hot, or if you just say heat, okay, that may not be accepted as an answer, right? So 5A part 2, complete the following sentence to describe how the mirrors direct energy from the sun towards the receiver. Okay, so we've got mirrors. Okay, how do they direct the energy from the sun, which is falling this way, onto the mirrors? How is it directed onto the solar receiver? So the answer to that is energy from the sun is reflected by the mirrors towards the solar receiver. So there's going to be sun rays coming through, being reflected off the mirrors onto the solar receiver. Okay, number 5A part 3, heated water is used to generate electricity in the solar thermal power station. Choose the correct answer from the box to complete each sentence. So it is the heated water which is used to generate electricity in the solar thermal power station, and it is water which is also used, heated water which is used in other power stations, such as the one which uses coal. The coal is just being used to heat the water up, okay, so that the water turns into steam, and the steam turns a turbine, and the turbine is coils of wire, and the coils of wire are cutting through a magnetic field, and magnetic field then induces a current inside the coils of wire, and that's how the electricity is produced. So it's the same thing which is happening here. So at the solar receiver, water is heated in a boiler, okay? So it can only be a boiler, okay? That's where you heat water. A lot of people have boilers in their homes, so that should be common sense, really. So water is heated in a boiler, okay? So boiler goes here, which turns the water into steam, okay? The steam, which is fast moving water molecules which have become which have started moving faster and faster than when it's just water. Okay, so they turn a turbine. Okay, and the turbine is connected to a generator. The generator produces electricity. Okay, a dash is used to change the voltage for the transmission along power lines. So a transformer is used to change the voltage for transmission along power lines, because the voltage which is produced is not high enough for transmission across power lines or along power lines. And if it's not big enough or it's not high enough, then a lot of current, a lot of the power is not going to be transmitted along. So we need a really high voltage in order to do that. So we need a step-up transformer. A solar storage power station is a new type of power station. It is able to store energy from the sun to generate electricity at night. Okay, one of the problems that we have with solar energy is that it is difficult to store the energy. Okay, so most of the power stations that use solar or solar power stations, traditionally they've had to work during the day, but now as in this example, a new type of solar power station has been produced and is able to generate electricity at night. The solar storage power station can supply a town with a maximum electrical power of 1,400 kilowatts for 15 hours. Calculate the maximum energy in kilowatts hours stored by the solar storage power station. Use the correct equation from the equation sheet. So without even looking at the equation or looking for what the equation is, you can just tell from the units of the answer, which is kilowatt hours, that it's going to be this kilowatt hours, this kilowatt times that hours, which means 140,000 times 15. So basically, if this is the power, which is measured in watts, and the hours is going to be the power times the time. So power times time would give us the kilowatt hours. Okay, so let's just go and write it down. Where shall we write it down? Oh, there. Let's just go and write it down here. So what we're calculating now is, let's just go back to the question, the maximum energy. So energy, so the maximum energy is equal to the power times the time. In this case, 140,000 kilowatts times 15 hours. Okay, now let's find my little calculator. So that's 140,000 times 15 gives you 123. That's a million, because that's 6. So it's 2.1 million. 2.1 million. So it's 2,100,000. Okay, and this is now kilowatt hours, and that is your answer to that question. Next question is 5C. A different method of generating electricity uses wind turbines. A student researching a wind farm wrote the following. Top Hill Wind Farm has 25 wind turbines. Okay, take note of the number 25. Last week, one of the wind turbines generated electricity for only 42 hours out of a possible 168 hours. My conclusion is that all wind turbines operate for only 25% of the time. So the conclusion that he has made is that all wind turbines, after observing only one wind turbine in the last week. So give two reasons why the student is not correct in reaching his conclusion. So his conclusion is wrong. It is based on saying 42 divided by 168 times 100%, giving him 25%. Okay, so what could be the reasons why the student is not correct in reaching this conclusion? Okay, so first of all, he's only considered one wind turbine. Okay, so considering only one wind turbine out of 25 is not enough to make a conclusion that all wind turbines operate for only 25% of the time. Okay, so the other reason is that some of the wind turbines might have actually operated for more than 42 hours or even less, or they could have operated for all 168 hours. So making that conclusion is wrong based on just one wind turbine. Okay, and the other reason is that he's only considered 1 week out of a possible 52 weeks in a year. Okay, so if he says for only 42% of the time and he's only considered a week out of a possible 52, again, that is not enough. Okay, and the other thing is that the wind might blow differently from week to week. So it might have been a week where that level of wind or that amount of wind was blowing. Okay, but it's possible that during other weeks there's going to be more wind blowing or less wind blowing depending on the time of the year. Now, give one reason why wind turbines do not generate electricity all the time. So for a wind turbine to generate electricity, it has to be blowing at a certain range of how fast it is blowing. Okay, so if it's too slow, if the wind is too low, then there is not going to be much electricity generated. Again, if the wind is too high, okay, if there's too much wind, then there is not going to be generation of electricity either. The wind has to be within a reasonable range of blowing. 5C part 3, give one advantage of using wind turbines to generate electricity compared with using fossil fuel power stations. Okay, so wind turbines they're a renewable source of energy, so that's one advantage. The other advantage is that it does not produce greenhouse gases, unlike fossil fuels. And you could also say that wind turbines do not, they do not cause acid rain. So you could talk about all the things that fossil fuels would cause to the environment and use that as an advantage of why it is better to use wind turbines. Okay, so that's the last of question 5. We'll leave it here and I will see you when we do question 6. My name is Derek Tafuma and my website is derektafuma.com. You can subscribe to this channel if you want more questions on physics, and I also talk about other things. I don't like to constrain myself to just one line of thinking, so I actually do other videos as well, but the physics videos are the main videos of this channel. So see you in the next video. Thank you.